Output layer. Number of neurons 10. W underscore O output. TF variable, TF random, under uniform underscore uniform of layer 1 neurons 1, minimum value -1, maximum value +1, that type TF dot float 32, P underscore O TF variable of TF zeros 1, 1, data type TF dot float 32. Build the model. Model equal to TF dot mat mul, that is matrix multiplication, H comma W underscore O means output. This one is also variable weightage plus P underscore O means output. PW are almost same category. Variable to be analyzed. Minimize the cost function. Model -y. Train underscore output TF train. Yeah, DAM optimizer. Minimize of TF neural network 12 plus model Y. Start the learning process, learning phase. Session TF session run. Now TF initialize all variables. Here have to be initialize all the variables in the start the learning phase session. Errors equal to, here will count. For I in range number under a focus. For start, end in zip, range 0, length of X training, batch size, range, batch size, length X training, batch size, session run. Now train OP, predict X training start end, Y training start end, cost, session run of TF neural network 12 loss model, Y validation, feed, dict X validation, errors append cost. If I 100 equal to 0, print of epoch cost, I cost. Plot, these are a plot graph. The graph errors will be plot in the graph. Label equal to MLP function approximation. X label, Y label, X label focus, Y label cost, plot legend, plot show. Output following is the representation of function layer approximation. Here this blue color train, this color validation. This color page color. EIGI. Here two data are represented in shape of W. Two data are train and validation, which are represented in distinct colors as visible in legend section. Instructions for updating. Use tf.global variables underscore initializer instead. Epoch 02 up to 1400. According cost also mentioning. For epoch 0 cost is 52 523.278. For epoch 100 cost 25.7673. If epoch increasing, cost also reducing. For 1000 cost 9.82508. For 1400 cost 1.04172. This one MLB function approximation. Y-axis cost, x-axis epochs 0 to 100 up to 400. Here 0 to 500. So like this flow. TensorFlow optimizers in TensorFlow. Next chapter. Optimizers are extended class which include optimizers are extended class which include added information to train a specific model. The optimizer class is initialized with given parameters, but it is important to remember that no tensor is needed. The optimizers are used for improving speed and performance for training a specific model. The basic optimizer of TensorFlow is tf.train.optimizer. This class is defined in the specified path of TensorFlow Python training optimizer.py Python. This is the specified path. Following are some optimizers in TensorFlow. Stochastic gradient descent with the gradient clipping, momentum, Nastro momentum, ADA grad, ADA delta, RMS probe, ADAM, ADAMAX, SMORM S3. We will focus on the stochastic gradient descent. The illustration for creating optimizer for the same is mentioned below. TF, SGD cost, paramus, ARMS, IR equal to NP dot float 32 of 0.01 G parameters. TF gradient cost parameters. Actually, generally, we have to put TF for TensorFlow before that conduct like this conduct. Updates for parameter G parameter in Z parameters G parameters. Updates append parameters assigned parameter IR G parameter. Return updates. The basic parameters are defined within the specific function. In our subsequent chapter, we will focus gradient descent optimization with the implementation of optimizers. TensorFlow, next chapter, XOR implementation. It is nothing but gate like OR and this one XOR gate is the opposite of the OR gate. In this chapter, we will learn about XOR implementation using TensorFlow. Before starting with the XOR implementation in TensorFlow, let us see the XOR label values. This will help us understand encryption and decryption process. A, B, A XOR B, 0 0 0, 0 1 1, 1 0 1, 1 1 1 0. Same will be 0, same will be 0, different will be 1. Result 1. XOR cipher encryption method is basically used to encrypt data which is hard to crack with brute force method. Encrypt is the important. By generating random encryption keys which match the appropriate key. The concept implementation with the XOR cipher is to define a XOR encryption key and then perform XOR operation of the characters in the specified string with this key which a user tries to encrypt. Now we will focus on XOR implementation using TensorFlow, which is mentioned below. Declaring necessary modules, import TensorFlow as TF. TensorFlow means TF only all the way. Anyways, import numpy as NP, always numpy, NUMPY, NP only. A simple lumpy implementation of XOR gate to understand the backpropagation algorithm. X equal to TF placeholder TF dot float 64 shape port comma 2 name X, declaring a placeholder for input to X, and then Y we have to declare expecting TF placeholder TF dot float 64 shape 4 comma 1 name Y comma name Y, declaring a placeholder for decide output. This is a very important. Optimized output, you can say. M equal to NP shape of X of 0, number of training examples. N equal to NP shape of X of 1, number of features. Number of training examples. This is number of features. Hidden underscore S, 2 number of nodes in the hidden layer. 1 underscore R, 1 learning rate installation. The tal TF cast, TF variable, TF random, normal, 3 hidden S, name the T1 TF dot flow float 64, the T2 T1 finish, then save TF cast, TF variable, TF random, normal. Here only change. Here 3 hidden, 3 comma hidden underscore S. Here hidden underscore S plus 1 comma 1. Name theta 2 TF dot float 64. Here theta 1. Here theta 2. Conducting forward propagation. A1 TF dot conduct NP dot C NP once X shape of 0 X 1. The weights of the first layer are multiplied by the input of the first layer. Z1 TF maximal function A1 theta 1. The input of the second layer is the output of the first layer. The input of the second layer is the output of the first layer. Yes. Output of the input to the first layer. Okay. Now, passed through the activation function, and this activate function like this. And the column of bias is added. Column of biases is added. A2 dot A2 equal to TF dot